Python has become one of the most popular programming languages. According to the 2023 Stack Overflow Developer Survey, Python is ranked as one of the top 3 most loved languages used by over 51% of developers worldwide. It's no surprise that almost every other company now prioritizes Python during technical interviews, whether you're applying for roles in data science, web development, or even automation. But Python interviews are not just about knowing the syntax. Companies look for skills like how well you understand the language, are able to solve problems, and apply Python in real-world scenarios. This video will help you prepare for the most common Python interview questions, giving you the confidence to tackle everything from basic concepts to more advanced challenges. We have bifurcated the 30 interview questions that we'll be covering in this video into 3 sections. First, we'll start with the most basic questions to help you brush up your fundamentals. Then we'll move on with the OOPS concepts and cover the most frequently asked questions revolving around it. Then finally, for the advanced level questions, we'll cover the data structures and algorithms questions, the frequently asked coding questions, and how you can prepare yourself for these concepts. But before we begin, quickly subscribe to the Intellipaat YouTube channel and hit the bell icon to never miss any update from our team. So whenever you enter any interview, the very first question that will be thrown at you is, what is your most preferred language? Once you give your answer, which will be Python in our case, then comes the real question, which is also the first question for our video. What makes Python different from other languages? Or simply, why Python? Companies are looking for programmers who know why they choose a language, not just what they code in. So when asked why Python, it is your chance to show you understand what makes it special. So you need to be very crisp and to the point while answering this particular question. Start with the popular features of Python and what makes it different from the other languages. For example, you can start by saying that Python is an interpreted language, dynamic, high-level programming language. Dynamic means that the type of variable is determined only during runtime, and hence one variable can have different data types at different times. Data types are checked during execution. For example, Python allows addition of a float and an integer but will throw an error if one tries to add a string and an integer. And high-level language means that Python is easy to read, manages memory for you, works on any system, and provides tools that let you focus on solving problems instead of dealing with the hardware. Second question that can be asked is, what do you mean by Python being an interpreted language? Do keep in mind that whenever you answer any question in an interview, the next question is going to be a follow-up for the previous question. And this question is one of that kind. So your answer for this question should look something like this. An interpreter allows the code to run line by line rather than being compiled into machine code first. This is why Python is easier to debug. We can take the analogy of cooking a meal. We follow one instruction at a time without worrying about the entire meal at once. Moving on to the next question, give 3 differences between lists and tuples. Now you might feel that this is an easy question, but the catch here is that the interviewer is not just looking for the basic concept, like square brackets are used in lists and tuples use parenthesis concept. You need to also have knowledge about mutability, memory usage, and performance. You can differentiate in pointers like first talk about mutability, that lists are mutable whereas tuples are immutable. Then for the second point, talk about memory usage. A list occupies more memory as compared to a tuple. Then the last point will be performance. List has slower iteration compared to tuples, but it is better for insertion and deletion operations due to its mutability. Now let us look at the fourth question. Differentiate between mutable and immutable data types, or simply what is mutability? This is a somewhat direct question, but make sure you elaborate the key areas and do not forget to include examples. So first, explain mutability. Mutable data types are those that can be modified after their creation, like lists, dictionaries, and sets. Say we have a list L containing elements A, B, and C at the indexes 0, 1, and 2 respectively. But later on we realize that instead of B at index 1, we want G. We can easily achieve that using slicing. Access the first index using square brackets and assign G using equal to sign. We can also insert an element or delete an element from the list using the append and pop method respectively. Mutable data types are used in cases where data requires frequent update. Now let us look at immutable data types. In the case of immutability, there cannot be any modifications once the data types like tuples, strings, integers, and floats are created. If in case of a tuple or string, we try to modify any particular element, it will throw an error. immutable data types are used in cases where we need to store data that will not change frequently. Moving on to the fifth question. What is the difference between slicing and indexing? This is again a very simple question if you're able to follow a proper structure while answering it. So slicing and indexing are both ways of accessing elements in sequences like lists or strings, but they work a little bit differently. Indexing is when you refer to a specific item in a sequence by its position or index. For example, if we have a list L containing elements 10, 20, 30, then using the list L and passing 0 in the square brackets would give me the first element, which is 10. It's just a way to grab a single element from the sequence. On the other hand, slicing is more about accessing a range of elements. It's like cutting out a portion of the sequence. For example, if I want the first two elements of the list, I'd use the list L and pass the range in the square brackets using a colon to indicate the start and stop value. That is 0, colon 2. And since I'm not passing any step value, it will be 1 by default. And that would return 10 and 20. Slicing can be really flexible. You can specify a start, stop, and even a step value to control how you are accessing the sequence. So in short, indexing is for accessing the element and slicing is for working with a range or subset of elements. Now let us move on to the next question. Explain list comprehension. List comprehension is a neat way to create new lists using a simple one-line syntax. It's a much more compact and readable alternative to using a traditional for loop. With list comprehension, we can generate a new list based on an existing one, applying conditions or transformations right within that single line. If we were to do the same thing with a for loop, it would take multiple lines, and as the logic becomes more complex, it can get harder to read and understand. But list comprehension simplifies this, making the code both elegant and efficient. Now let us look at the seventh question. What is the difference between break and continue? So in order to differentiate between the two control flow statements which determine how and when certain sections of the code should be executed or skipped, you can also use the analogy of a person watching a movie to back up the definitions you give to the interviewer. First, define what the break statement does. So the break statement will terminate the very loop inside which it is used and move the control to the statement that follows the loop. It is like stopping the movie midway and leaving the theater and then continuing with whatever action you would normally perform after watching the movie. Continue statement is used when you want to skip a part of the movie but watch the rest. Basically, the continue statement terminates the current iteration of the statement and transfers the control flow to the next iteration of the loop. Moving on to the next question. What is the pass statement? The pass statement is generally used to fill up an empty block. Basically, when there's a movie scene where nothing happens, you just keep going without stopping or skipping. The pass statement in Python is essentially a placeholder. It doesn't perform any action when executed. It's often used when you're writing code and want to leave a certain section empty for now but don't want to run into errors. In Python, an empty block of code will raise an error, so pass comes in handy to avoid that. It is a no operation statement. For example, if I'm designing a function or a class but haven't decided what the implementation will be yet, I can use pass to fill in the space, allowing my program to run without issues. Then we have our ninth question. What do you understand by scope? Scope is the area in a program where a variable or a function is accessible. To put it simply, it tells where you can use or interact with a certain variable or function. There are two types of scopes, global and local. When a variable is defined outside of any function or block, it's accessible from anywhere in the code. In such cases, the variable is said to have a global scope. For example, a book that is placed on a public shelf so that anyone in the library can access it. But on the other hand, when a variable is defined within a function, it can only be accessed inside that function. In this case, the variable has a local scope. It's like placing a book in your drawer so that only you can use it. Moving on to our next question, what are negative indexes and why are they used? Negative indexes allow you to access elements from the end of a sequence, such as list or string, rather than from the beginning. It's like counting backward instead of forward. Typically, when you use a positive index, you're accessing elements from the start, with 0 being the first element. But sometimes it's more convenient to start from the end. That's when negative indexing comes into play. This feature is useful when you don't want to calculate the length of a list or string to get the last few items. For example, if you want to quickly access the last character of a string, you just have to pass -1 in the square bracket to access the character using indexing. So now let's look at a more implementation-based question, which is how do you copy an object in Python? Now, there are various ways of copying an object. Let's look at all of them one by one, right? So when we use an assignment operator, what we do is say our one variable is pointing to a certain list which contains 1, 2, and 3. And when we use assignment operator to create a copy of this very list, what it's going to do is the other variable also points to the same object, right? It just creates a reference for the other object which point to the same object in the memory, right? So what happens is, basically, instead of creating an actual copy of an object, we just create a reference. Both the variables basically point to the same memory in the object. So any changes made through one variable should reflect in the other variable as well, right? So if I say a dot append, so basically B will also reflect the same changes that are made in the a variable. But if we want to create actual copies of objects, especially when we want independent copies, we can use the copy module that is available in Python, right? It gives us two ways to copy an object, which is the shallow copy and the deep copy. So as you can see in this diagram, so having its own separate elements, as you can see, bag 1 has its own separate elements, whereas bag 2 has its own separate elements. Whereas in shallow copy, again, a reference is being created where both the bags over here, or in case of Python, both the variables are going to point to the same object, right? Let's go ahead and look at them in detail. So shallow copy is like copying the surface of the object, right? It will create a new object, but it will not fully duplicate the nested objects inside it. So if we consider a nested list, so say we have a nested list. I will show you guys the implementation of this code in my VS Code. But before that, understand the concept behind it, right? So in case of nested list, only the references will be copied, right? Any changes to the inner elements or the elements that are inside the nest of the list will affect both the original and the shallow copy. Let me take you to the code. So as you can see, I have imported my copy module, and when I use, and I have my list over here, which is containing elements 1, 2, and 3 and 5 over here are nested. So at index 2, I have a nested list, which is containing 2 elements again. At index 0, I have 3, and index 1, I have 5. And then at index 3, I have another element 4. Now, if I use the shallow copy method, which is just copy in my copy module, and I assign 7 at index 3, which is basically I am replacing 4 by 7, and then I'm appending 6 at index 2. So 0, 1, and 2. So index 2 is my nested list, and inside my nested list, I'm appending an element 6. So when I make these changes in my list 2, these changes shouldn't have reflected in my list 1. But when we print both the lists, so the changes inside the nested list, as you can see over here, is reflected both in my original list and my copied list. But outside over here, the element that was replaced is not reflected in my original list. So this is how shallow copy works, right? But in the case of deep copy, it will create a fully independent copy of the entire object, including all the nested objects as well. So this can be done using the deep copy method from the copy module itself. Let me quickly show you. So this is how the deep copy syntax works, right? You just have to import deep copy from the copy module and pass your original list and assign it to the variable that you want it to be copied in. And now whenever we make any changes, it will not reflect in my original list. As you can see, I have copied my list 1 in a variable called list3, and then at index 3, I'm replacing 4 by 8, and then I'm appending 7 in my nested list. So as you can see over here, the changes are being reflected only in my copied list, which is list 3, but my original list remains the same. So this is how shallow copy and deep copy work. I hope this is very clear to you guys. So this is the syntax of the shallow copy and deep copy methods, which I've already shown you guys on my VS Code. So this should be really easy to understand. This is my original list in the variable list, and I am shallow copying it over here and storing it my variable L2. Similarly, I'm performing deep copy over here. I have passed my original list, which is stored in variable list again, and I have used variable L2 to create a deep copy of my original list. So moving on to the next question, which is what does star args and double star keyword args means, right? So whenever we are creating a function and are not sure about the total number of arguments that will be passed, we use the arguments, which is args or keyword args, as parameters.
Yeah.
Right, so this helps the function to take a variable number of arguments and not throw any error. Say I have a function, let me just get my pen over here. Say I have a function person, which is basically used to print the details of a person. So say I have name, age, and then I have optional arguments also. Maybe I have the degree of a person or the qualification or the job status and arguments like that, right? But not every person is going to fulfill all these criteria. Now, if I pass all the parameters beforehand and if some person does not have those features or those qualifications, my function is going to throw an error, right? So to avoid that, what I'm going to do is I'm simply going to pass star args as my next parameter. And so this is how that function is going to handle all my extra arguments or my lesser number of arguments, right? So star args basically allows you to pass a variable number of positional arguments to a function. It collects these arguments into a tuple. So we're going to look at their implementation in our VS Code. But before that, let's just understand the difference between star args and double star keyword args. So basically, keyword arguments basically allow you to pass a variable number of keyword arguments. So now they collect these keyword arguments into a dictionary. So basically, whenever we're passing arguments in our function, we can pass them as, say, I want to pass person and I have my name, I have my age, and then I want to pass, say, qualification. So I will just say qualification and I will pass the qualification. Say I want to pass the degree, I will say degree and pass my degree over here. So this is how keyword arguments work, right? So this is the syntax. Whenever we're creating a function and we're not sure about the total number of arguments that a function is going to take or the total number of parameters, we just pass star args and double star keyword arguments. So on printing these arguments, you will realize this is a tuple and this over here is a dictionary. And star over here means variable length, right? So this is what we're basically trying to implement over here using star and double star keyword arguments and normal arguments. So as you can see, I have a function created over here called test. It's taking normal arguments and keyword arguments. So let's understand this. But first, let's see what we're passing in our test function, right? So we're passing 1, 2, and 3. So these are our positional arguments. These are the arguments that our normal argument parameter is going to take care of. Whereas name equal to Alice, age equal to 30, city equal to New York is something that our keyword arguments are going to take care of. So when we print them, let me just quickly run this function. So on printing, you can see I have my positional arguments 1, 2, and 3. And then I have my keyword arguments. My keys are basically the name, age, city, and my values are Alice, 30, and New York. So this is how keyword arguments and the normal arguments parameters function and take care of the variable number of parameters that you want to pass in your function. Moving on to the next question, how are arguments passed by value or by reference in Python? So passing by value is basically copy of the actual object that is being passed. whereas pass by reference is basically reference to the actual object that is passed. Now, you might have come across these concepts in other languages, in other programming languages like Java and C, but in Python, arguments are not passed by either of the two. They are actually passed by assignment or passed by object, right? So this is basically a trick question that the interviewer is going to try and ask you to trick you into picking one of the two options, but you need to be very clear. You need to start by explaining pass by value and pass by reference. We can just give one line definitions and move on by saying that in Python, none of these methods work. Rather, we have pass by object method that actually is being implemented in Python. So passing by object basically works like this. When you pass a variable to a function, what actually gets passed is a reference to the object the variable is pointing to, right? So say I have a function and I'm passing a variable to it. So whatever my variable is pointing to, that object, the reference to that object is being passed in my function, right? Now the behavior of how things process afterwards depends on the type of the object. So now my objects can be of two types, which is mutable and immutable. So mutable objects are again objects that allow changes made inside them once they're created. But mutable objects, when we're talking in terms of passing inside the functions, they're basically changes made to the object inside the function will reflect outside the function as well. And immutable objects are basically when you pass these objects, any modification that are made to these objects inside the function, they're not going to affect the original object. That is, when you access these objects outside the function, they are going to be, they're going to point to the original value that was stored inside them, right? So let us quickly look at the implementation of passing by object. So as you can see, I have a list over here and I'm printing my list. Let me run this function also so that you can understand side by side. So before modifying my list, it was 1, 2, and 3. And then I go ahead and modify my list, which is basically I'm passing my list in this modify list function. And what I'm doing inside this function is basically I'm appending an element 4 and then printing my list, which was passed inside the function after the modification. So inside the function, my modified list contains this element which I just appended. But what if I try and print it after the modification as well? So after I print my original list, after it was passed in this modify list function, it also reflects the changes in the original list. So this is how the mutable objects function when they are passed to any functions. But what if I pass an immutable object? So my immutable object over here is a number 5. So I print it before passing it to my modify number function. It is 5. And then I pass it to my function. I increase the value by 10. So initially it was 5. Now it becomes 15. When I print the value inside my function, it is showing 15 over here, which is correct. But after I have passed my function, I print the value outside the function. It is giving its original value, which was initially stored over here. So this is how mutable and immutable objects function when they pass to a function in Python. Moving on to our 14th Python interview question. What is lambda and why is it used? So in Python, lambda is a small anonymous function defined using the lambda keyword, right? So in Python, lambda is basically a small anonymous function. Anonymous is basically we do not need to define a name for a function, say def func. We do not need to give a particular name to our function before implementing it, right? So it is anonymous and it is defined using the lambda keyword itself. So unlike the regular functions in Python that are defined with the keyword def, these lambda functions are used for the short and simple operations where you do not need to formally define a function, right? So a lambda keyword can take any number of arguments, but the only constraint here for the lambda function is that they can only have a single expression. So they're often used as arguments for functions like map, filter, and sorted, where you need a small function for a specific task. They basically help in increasing the readability of the code, right? So what's happening here is basically we're defining our function lambda, and then we are passing an input variable, and we're giving an expression that this is what is supposed to be done with the input variable. So say our x is 2. So our expression is going to perform the operation which is 2 star 2, which is x star 2, which is basically 2 star 2, and it's going to give the output 4, right? So this is how the lambda function works, which is really short to implement. Let me show you the implementation in my VS Code. So as you can see, I have a list called numbers where I have numbers 1 to 5. And what I am doing here is I am basically squaring these numbers. So if I were to write a for loop, it would at least take me 2 or 3 lines of code, right? But over here, I can just do it with my map and lambda function. So what I'm doing here is I'm passing my input variable x, and I'm giving the expression that it is supposed to be multiplied with 2. So my each input has to repeat. So my each input has to be multiplied by 2. And I'm giving my input list over here, which is numbers. So I'm telling my function that this is my input parameter, and it is supposed to access each element one by one and multiply it with x and store it in a list, right? So let me run it and show it to you. So that it has mapped each input variable with my expression over here, which is my output, and given me a list which is 2, 4, 6, 8, 10 square of all these numbers. Sorry, not the square, but the multiplication of 2 with all these numbers. Then the next question is exceptional handling. So in order to avoid your code or program to crash due to any error, we use the try and except block, right? Be it the dividing by zero error or any syntax error or even the file handling error. These are the errors that you get while running your code or while reading or writing into files, right? So whenever you feel that a piece of your code or a part of your code has the potential of raising an error, all you have to do is put that piece of code in the try block. So if there is any error in the try block, it will quickly jump to the except block and handle it without raising any errors, and it will also allow a smooth functioning of your code, right? But if there is no error in your try block, it will just continue with your program and move on to your else block. And then you can even use a finally block to execute code no matter what, regardless of whether an exception occurred or not, like closing your files or freeing up resources. These actions can be performed in your finally block because this block executes no matter what, right? So exception handling is performed to avoid any code crash. Now, how that is done? The code that could throw an error is put inside the try block. So if the code does throw an error, the except block handles the error. So this is the syntax for exception handling. So what's happening here is I'm dividing a number. So what this result variable is storing is basically a number being divided by 0. Now, in case you have a doubt whether it's going to throw an error or not, you put it in a try block so that your code does not really crash, right? And then you can simply print your error over here so that your code ends in a very neat and clean manner, right? So let me quickly show you the implementation of my code over here. So as you can see, it prints, oops, you can't divide by 0, which is the except block handling the error that we have tried to avoid in my try block. And then the finally block gets executed and prints this line of code. This code will execute anyway. Right, so I hope you guys got a basic understanding of how the try and except and the finally blocks are used and implemented in Python. Moving on to the next important question, which is memory management in Python. Now, this is a very frequently asked question in most of the Python interviews. So unlike the other programming languages, memory management in Python is handled automatically by a system called garbage collection and a private heap space, which store all the objects and the data structures. So in order to understand what these are, first let's quickly look at this diagram. So we have our two objects that are being stored in our memory. So this circle represents the memory. or the heap, and we have a reference count, and we have a stack over here. And what basically is happening here is whenever the reference count becomes 0, the object gets ready to move into the garbage collector, right? So until and unless any object is being referred by a variable, so an object stays in the heap only until it is being referred by any variable. As soon as the reference count becomes 0, it is moved to the garbage collection. So let's understand these terms in a detailed manner. So Python basically has a built-in garbage collector that handles the circular references. Circular references are basically when two objects refer to each other but are no longer needed, right? So basically their reference count is 0. We'll understand what reference count is. So the garbage collector basically identifies these unused objects and then clears them, ensuring efficient memory usage, right? So a private heap is basically a heap that contains all the Python objects and data structures, right? Unlike the other programming languages like C, you do not need to manually allocate or free memory in Python, right? The interpreter takes care of it. And then comes reference counting. So every object in Python has a reference count, which is basically a track of how many variables or objects refer to that object, the object that is in the heap, right? When the reference count drops down to 0, meaning no one is using it, right? So Python frees up the memory for that object. Basically, it moves that object to the garbage collection. So this is how reference counting helps. So this is how reference counting basically keeps track and helps moving the objects from the heap to the garbage collection, right? So let's move on to the next question, which is differentiate between sorted and sort. So now you might be wondering, sorted and sort are both used to sort the data, right? But they do differ in how they function and how they're applied, right? So let's look at sorted first. So sorted basically returns a new list. So whenever a list is passed in the sorted method, then this method does not actually change the original list. Rather, it creates and returns a new list which contains the sorted elements of the original list, right? That means it is not just limited to lists. It can work on tuples, it can work on any sort of iterable that is being passed in the sorted method. The syntax is very simple. The iterable, it could be a list, tuple, or any other object. And we have our key equal to none. Key is basically the function that serves as a custom sorting criteria. And then we have a reverse, which is by default equal to false. If we use reverse equal to true, the result is going to be sorted in descending order, right? So these are the parameters for sorted. Now let's look at sort. So sort basically modifies the list in place. So whenever a dot sort method is used, the original list is going to be modified rather than creating and returning a new one, right? So it is an in-place operation. It works only on lists. Now there is one reason for this. If we perform this operation on tuple, since this method modifies the object that is being passed, now this is where you need to connect the dots, right? Lists are mutable, whereas tuples are immutable. And since sort is an in-place operation and it modifies the object in place, tuples cannot have any modification since they're immutable. So they work only on lists, where you use dot sort for the list that you need to sort and pass the key and reverse as optional parameters. And these key and reverse work the same way as sorted, right? So the key difference between sorted and sort is basically the return value. You can say sorted returns a new sorted list, leaving the original list unchanged, leaving the sorted list unchanged, untouched. Whereas sort method modifies the original list and does not return anything, right? It returns none. The next point is the scope. So sorted works on any iterable, whereas sort is restricted only to lists, right? So these are the major key pointers that you can give as differentiation between the two methods for sorting, right? Moving on to the next question, which is what is compile time and runtime error? Do they exist in Python? So you can think of compile time errors as mistakes that are caught before the program actually runs, right? So these errors are usually related to syntax. Python has an interpreter that reads through your code before execution. As we already discussed, Python is an interpreted language, which basically means that your code is read line by line, right? So before the execution of your code, Python's interpreter reads the code line by line and it needs everything to be structured properly or it raises an error. So you can call this error as compile time error, right? So say for example, you're typing up an email and the spell checker that you use, it could be Grammarly or any other spell checker that you use, it underlines mistakes for you as you type, right? So this can be an analogy for compile time error in Python. So, but the thing is, in Python, we do not use the term compile time, rather we use syntax error. Uh, but the thing is, in Python, we do not use the term compile time error, rather syntax error is more preferred, right? Moving on to runtime error. Now moving on to the runtime errors. So the runtime errors happen while your code is running, after the syntax is checked and the program has started to execute, right? So basically your interpreter has gone through your code line by line and has given you a go signal that you can go ahead and execute it. So these errors usually occur because something unexpected happened during the execution of the program that the interpreter wasn't prepared for, right? Right. So an example of runtime errors or an analogy with a real life situation would be, say, a person driving on a smooth road and then all of a sudden a bump or a pothole arrives and the person has to suddenly apply the brakes, right? So everything was going fine, but then something unexpected disrupts the flow. That is something known as runtime error, right? So now the second part of the question is, do they exist in Python? So you need to tell the interviewer that yes, they exist in Python, but also mention at the same time that compile time error is known as syntax error, right? In Python, we do not use the term compile time error, but rather we use it as syntax error. So both types of errors exist in Python. And Python handles everything else as runtime errors, which can include things like type errors, index errors, or exceptions that are only detected once the code is in action. We can start by saying yes, both types of errors exist in Python, though we do not use the term compile time error, rather we use syntax errors, which serve the same purpose. And you can continue and say Python handles everything else. All the other errors like the type errors, index errors, or exceptions that are only detected once the code is in action as runtime errors, right? So this is how you're going to wrap up your answer. So before we move on to the next question, let us quickly go through the compile time error code once. So as you can see, this is my code and I have missed a semicolon over here. And let's see what happens, right? So as you can see, missing colon and expected over here, and it is giving syntax error, right? So compile time error, basically before running the code, when our interpreter is going through it line by line, it reaches here. So now as we studied that Python uses an interpreter and interprets the code line by line and raises the error wherever the structure is not matching the interpreter's expectations. So it will print hello before raising an error, right? Let's try and run it. So that was all about compile time error and runtime error. And we also saw how they are implemented in Python and what is the kind of error, the syntax error that is raised in compile time error, right? Now let's move on to the next question. What are generators and decorators, right? So now this is a combination of two questions. Usually generators and decorators are not asked together in one question. But in order to avoid any confusion, I have put these two questions together so that you can also know the difference between the two, right? So first, let's look at the generators. So generators and decorators are basically two powerful tools in Python that help make code more efficient and readable. But they again serve very different purposes. As I told you, these are supposed to be two different questions. They have no interlink whatsoever, right? So let's look at the generators first. So generators are a function that basically return an iterator. So using this iterator, we can iterate over one value at a time. So instead of returning all the values at once like a normal function, a generator yields values one by one, which makes them more memory efficient. So this is again done using the yield method instead of the return method. So as you guys must have noticed that whenever we create a function, any function, we usually return the value at the end. But whenever we use generators, we use the yield method instead of the return method. So this is useful when dealing with large data sets or infinite sequences, right? So say for example, if you need to process each line of a huge file, you wouldn't want to load the entire file into memory, right? It would firstly affect the performance of your machine and also make it difficult to read the entire data set or the entire file at once. So this is where generator comes in the picture, and generator allows you to process each line as it is needed, one at a time. So again, it is helping in making your code look neat. It is helping in the understanding of the data. Another important feature of the generator is that they remember their state between each line, right? So say you have 10 lines of file and you yield the first two lines and then you take a break, you take a pause. So what the generator is going to do is it is going to keep its pointer over here. So first it read this and then it moved on here, and then it is going to stay here until you yield or until you retrieve the data again, right? So it remembers its state between each yield. So the next time you call the generator, it picks up where you left off. So this makes them very different from the normal functions which always start fresh, right? If you were to call a normal function, it would start from here always. So this is a basic illustration of a generator. So we have a for loop over here. So we have a for loop over here which is iterating through this tuple which is containing 1, 2 and 3. And so we have a for loop over here which is iterating through this tuple containing 1, 2 and 3 elements. And basically we're trying to return I plus 1. So when I is equal to 1, it is going to return 2. And when I is 2, it is going to return 3. And when I is 3, it will return 4, right? So this is what is happening over here. If we were to run this loop directly, we would just get all the output at once, right? What we are passing it through a generator, and this generator is going to return an iterator through the yield method, and this is going to be our output, which is going to be retrieved one by one, right? Let us quickly go ahead and look at an example. So let us go ahead and quickly look at how generators work, right? So as you can see over here, I've created a countdown function and it is taking a parameter num. Now, you can see I've created a for loop and I'm passing 5 as my argument in my countdown function. Now what this for loop is doing is basically it is going to print the count. Now whatever the countdown function returns or yields is going to be stored in count, and then we're going to print it over here, right? So let's look at the countdown function. It is going to check whether a number is greater than 0. If it is greater than 0, we're simply going to yield the number. Yield is basically another method of returning it. So we store this number in count and it is going to print over here. And then we go ahead and decrement the number by 1. So this process is going to repeat until the process is 0, right? As you can see over here, I get my output as 5, 4, 3, 2, 1, right? Okay, what if I were to use return instead of yield over here? So you can see int is not an iterable, so I get an error, right? So this will not work in the case of return, and this is why yield is used in generators. Then we have our decorators. So what the decorators do is basically they modify the behavior or the pattern of a function or a class, right? It is pretty evident by this image. So we had a yellow color fruit. You can consider it as a mango, or so you can see we have a fruit over here, and when we pass it in a decorator, the color changes, right? So we are not modifying any core property of this fruit, rather we are just changing its behavior, right? So this is what decorators do in Python. They're often used to add functionality to an existing function. Basically, they extend the functionality of an existing function without changing its code, right? The core functionality remains the same. Only the behavior or a certain feature of it is extended. So decorators take a function as an input or as an argument, they add some behavior and then return a new function. So this is useful for cross-cutting concerns like logging, authentication, or timing how long a function takes to run, right? Let's look at our decorators. Let's see how they are implemented in Python. So as you can see, I have created a function greet, and all I'm doing in this function is I'm printing hello, right? Now what this @decorator func. So this is the name of my decorator function over here that I've created. And using @ before this is basically a shortcut to this syntax. So basically I am creating a variable greet and I'm calling my decorator function decorator func, and I'm passing my greet function as an argument, right? So this is a great shortcut for the entire syntax. I just have to write @decorator func, right? So I've already created a variable greet, and all I have to do at the end is call my decorated function. So once I apply this method, this greet variable becomes my decorated function. Now let's go ahead and look at my decorator function. So as you can see over here, I've created a wrapper method inside which I am modifying the functionality of my function. I am printing that something is happening before the function, and I'm printing something is happening after the function, and in between I'm calling my function as well. So once I have modified the functionalities completely, I will just simply return my wrapper method, and upon calling my decorator function, this is what is going to be returned. So I have simply modified the functionality, whereas my main function remains the same. I have not touched my greet function. I have just modified it using a wrapper function. So this is how decorators work, and they are used to extend the functionalities of an existing function without changing the code. So let's quickly summarize generators and decorators. So generators create or return iterables one at a time, and decorators are about wrapping or extending functionality of an existing function, right? Simple enough. So pretty simple, right? So let's move on to our next question now. What is the difference between abstraction and encapsulation? So now we have entered our OOPS concepts, and abstraction and encapsulation are a very important topic under this concept. Even though they serve very different purposes, coders and users tend to get confused between the two terms, right? So first let's look at abstraction. So in order to differentiate between the two, we'll go ahead and explain the terms individually. So first we'll look at abstraction. So abstraction is all about hiding the complexity of a system and showing only the essential details to the user. So basically what abstraction is doing is it is focusing on the what rather than the how. It is not going to show you how the brakes of a car are functioning. Rather, it is just going to show you the interface or the application, the brake, where you can just go ahead and use it, right? So what abstraction is doing is basically it is focusing on the what rather than the how. By using abstraction, we're providing a simplified interface while keeping all the intricate workings of the system hidden, right? We do not want to show the user how our application is working. Rather, we just want to give them a very smooth and interactive interface, right? So this is a functionality of abstraction. So let's consider an example here. So say you're driving a car, you will only care about pressing the accelerator to make it go faster and the brake to make it go slower, right? That's a basic functionality we understand about the car when we're driving it. We do not need to know how the engine works, how the fuel is burned, or how the brakes are actually stopping the car, right? So that is how you can relate abstraction. So this is how you can relate abstraction with the real life examples, right? So this is how you can relate abstraction with real life examples. So now let's look at this image over here. We have our methods taste and color. So now you can consider these as the parent class. So they are just implementing these methods. They're just implementing, say we have a class and inside which we have these two functions. So you can see the function taste and the function color are just being implemented and they are not doing anything, right? And then we have our child classes, which basically inherit from the parent class and implement these methods, taste and color, and implement their functionality. So we can provide these implementations in the child class itself. So we are not worrying about how these are being implemented. Rather, we are just passing our features. That is, I want this fruit to be tangy and the color to be tangerine. I want this fruit to be sweet and the color to be yellow, right? We're just looking at the outer surface rather than understanding how this came to be. So now that we have understood the theoretical part, let's go ahead and look at the code implementation in Python. So in order to implement abstraction in Python, from the ABC method, you can import the abstract base class method and the abstract method. So we have created a parent class animal over here, and we have passed our abstract base class ABC as a parameter, and we have called our abstract method over here, and we have created a function make sound and not implemented anything, right? And then we create a child class or a subclass dog, and we inherit from the animal class, and we simply implement the make sound function and print bark, right? So we are not bothered with how the make sound function came to be or how it is being implemented. We are just, so it is up to the dog class over here to implement the make sound function in whichever way it wants, right? So this is one example of abstraction. The next point is encapsulation. So as you can see over here in this image, there's a capsule, and in one part of the capsule we have our variables and our methods, and in the other part we have our class, right? So this is an analogy for encapsulation in Python, how it works. So encapsulation is basically encapsulating all our attributes, all our data, all our methods, and protecting them, right? Let's look at them in detail. So encapsulation, on the other hand, is about restricting access to certain parts of an object or a class to protect its details, right? It hides the internal details of how an object works, how it functions, by bundling the data or the attributes and the methods or functions into a single unit or class. So how it hides the details is by making those certain attributes private. So it can easily make any attribute private by using the double underscore as a prefix. So say I have an attribute balance, which basically stores the balance of my bank account. I need to keep it private because I would not want it to be accessed just like that, right? So I'm going to keep it as a private variable by using the double underscore. Now this attribute can be accessed within the class in different methods, but outside the class, for any instance, it cannot be accessed directly, right? So it is going to raise an error whenever an instance of the class or an object is going to try and access this private method. So in order to understand encapsulation in detail, let's look at the code for encapsulation. So as you can see, I have my class car over here, which is implementing the function accelerate and the function get speed. So whenever I call accelerate, it is going to increase my speed by a certain value. And whenever I access get speed, it is going to return the current speed of my vehicle. Now, as you can see over here in my dunder method, I have declared my speed variable and initialized it to 0. But the only different thing over here is I have used a double underscore as a prefix for my attribute speed. So now this becomes a private variable or a private attribute. So now you can see I have instantiated my object car using the variable car, and I'm trying to access my speed over here. So when I run my program, I get an error, car has no attribute speed, right? I cannot access this private attribute outside my class. But what if I want to just print my speed, right? I want to know what the speed of my vehicle is. So I can use the method get speed, and I will pass it in a print function to print the value. And I will pass it in the print function to get the value. So you can see I got 0 as my output. If I were to increase the speed before printing it, I would simply tell my program to accelerate, and I would pass the value, say 10, right? I want my speed to be accelerated by 10, and now my current speed is 10 because initially it was 0 and it is getting incremented by 10. So you can see I will be able to perform all the other operations that are available in my class, or I will be able to access all my functions, but I will not be able to access my private attribute directly. So this is how encapsulation works. This is how encapsulation works in order to protect the car's internal state and in order to prevent any outside control. We made the speed variable private, right? So it cannot be modified through illegal means. So the main goal of encapsulation is one, to prevent direct access to the data, which also applies the concept of data integrity, So the main goal of encapsulation is one, to prevent direct access to the data, which also applies the concept of data integrity. So the main goal of encapsulation is to firstly prevent direct access to the data, which also applies the concept of data integrity. And the other is to show only what is needed, which is also known as abstraction, right? So you can say that abstraction is a functionality of encapsulation. So that was all about these two important OOPS concepts. Now let's move on to our next question. What is method overriding and how is it different from method overloading? Now this is an important question because again, method overriding and method overloading are quite confusing, and people tend to mix up with the two concepts. So in order to understand overloading and overriding, let's look at this diagram really quickly. So in overloading, you can see I have a function my sum, right? And as you can see, it is taking variable number of parameters. So whatever may be the functionality, you can see the first time I'm calling it, I have two variables over here. I'm adding two numbers, and for the second time I'm calling it, I have three parameters or three arguments that are being passed. So this is what overloading refers to. Whereas overriding, as you can see over here, I have a parent class. I'm implementing the function mySum, and I have two variables A and B. But when the child class inherits from the parent class, it is going to apply the same functionality, but the only difference is the parameters are going to be different. Now, in case of overriding, we have a parent class implementing the same method, mySum. Maybe it is performing some operation. Maybe it's adding the two elements over here that are being passed as arguments, right? So as you can see, in case of overriding, we have a parent class, mySum, and it is taking two parameters, A and B, right? Now this parent class must be applying some method, some functionality to this method, right? But when we inherit this very method in our child class, the functionality or the behavior of this method could change, right? So this is what refers to overriding. Let us go through these concepts in detail. So method overriding and method overloading are both ways to achieve polymorphism in object-oriented programming. But again, they work in very different ways, right? So method overriding happens when a subclass provides a specific implementation of a method that is already defined in its parent class. So we're basically changing the functionality or the behavior, or the child class overrides the behavior of the parent class's method. The key point over here is that the method, that is like the names and the parameters, remain the same, but the behavior changes. As you can see in this image over here, we have the same parameters that are being passed, A and B, but again, the functionality or the behavior for both of these classes, or both of these methods that are being called in the parent class and the child class, will vary greatly, right? So the subclass basically extends the features of the parent class. This allows the child class to provide its own version of the method that better suits its needs. And then we look at method overloading. So method overloading in languages like Java or C++, method overloading allows you to basically define several versions of a method. Each are designed to handle different input. But in Python, overloading isn't supported directly. Again, like we cannot say that Python directly supports overloading. Instead, Python typically handles it using default parameters or by checking the types of arguments manually. So now that we have understood overriding and overloading, let's go ahead and look at their implementation in our VS Code. So first, let's look at overriding. So we have a class animal and we have a method implemented in our parent class which returns some sound, right? So this speak method over here returns some sound. And then we have a child class dog which is inheriting from the parent class animal, implementing the same function over here, but returning a different output, right? Over here there is some sound and over here there is bark. So basically this child class is overriding the speak method, which is basically extending the feature of the speak method and returning a different output, right? So when we instantiate the dog class and access the method dog.speak, our output is simply going to be bark, right? So it has overridden the initial output that was supposed to be given by the animal class or the parent class. And then we have overloading. So we have a class math over here, which is basically implementing an addition function, taking the input A, B, and C. We have initialized C as 0. So this function is basically going to add all these arguments and return them. So the first time we call this method, we pass only two arguments, 2 and 3. Now since C has already been initialized as 0, it will not throw any error, right? It will just consider C as 0 and add 2, 3 and 0 and return the sum, which is 5, as you can see over here. The next time we call this method again, we pass 3 arguments, 2, 3 and 4. Now instead of 0, C takes the value of 4 and returns the output as 9. So this is how overloading is performed in Python. Moving on to the next question, how does inheritance work in Python? So whenever we hear the word inheritance in our day-to-day lives, we think of assets, we think of property being inherited by the children from their parents, right? So this is a similar concept that is implemented in Python. So inheritance in Python is again a key feature of OOPS that allows one class, that is the subclass or the child class, to inherit the attributes and the methods from another class, which is the parent class or the superclass. So this application or this methodology promotes code reuse. So whenever a child class inherits from a parent class, it automatically gains access to the parent's class's methods and attributes, meaning you don't have to rewrite them, right? So whichever methods, whichever functions that have already been implemented in the parent's class, we can directly use them in our child class. This wouldn't be possible without inheritance, right? Our code would raise an error if one class directly tries to access the attributes or the methods of another class. This is where inheritance comes in the picture. Inheritance will allow one class to access the features that have already been implemented in the other class. So accessing is one thing. The child class can also extend or override these methods to change or add functionality to the existing methods, right? We can take the example of a real-world application would be a vehicle whose attributes and methods would be again applicable to all the types of vehicles, such as different makes and models. So all the models, all the different brands would have 4 tires, would have 4 windows, would have some common features that can be accessed from the vehicle class itself. So let's quickly look at the implementation of inheritance in Python. We have a self variable name. We have implemented a method speak, which returns name and makes a sound, right? And then we have a subclass, our child class dog, inheriting from the animal class over here, as you can see. And we are overriding this method speak and returning name bugs, right? So we have overridden the function, we have inherited and overridden it. So you can see we have nowhere implemented the name function, but we can directly use it because we have inherited from the animal class. So let's run and see it. So, right, so it prints Buddy barks. we have given an input for name as Buddy, and it is printing Buddy Barks for the dog instance, right? So this is how inheritance works. And then we have a next question, which is again a very important one. What is the significance of self in Python classes? Right. So as you have already seen, most of the codes that we have implemented till now use the word self. Right. Whenever we use the dunder method in it, we had the self keyword as parameter. So in Python, self keyword is like the glue or a bridge that connects an instance of a class with its methods and attributes, right? So whenever you create an object from a class, you need a way to refer to that specific object inside the class's methods. That's where self comes into play. Let's relate it with a real world example, right? Uh, just suppose you're working in a company and each employee in that company has a badge with their name on it. Now, if you want to personalize a message to each employee, you need to know who they are, right? Self is like the employee's badge. It lets the methods in the class know who they're working with. So it basically connects the instance of a class with the associated methods and attributes, right? So that is the main functionality of the self keyword. And as you have already noticed, whenever you define methods inside a class, the very first parameter that is always passed is self, and it refers to the object that's calling the method. So this allows each object to have its own data, which is very crucial for OOPS. Now, this is also what differentiates instance attributes from local variables. Now, say I have a function which again takes self and let me just write it neatly. So in order to understand the self parameter, let's look at this example, right? So we have our class employee, which is taking the name and position as its arguments. And as you can see over here, we've implemented a greet method, which is basically introducing the person. It is saying, hi, I am, and it's going to print the name of the person, and I work as, it is going to print the position of the person, right? So here we create an instance of employee and we pass John and manager as name and position respectively. And then we call the greet method. So using this object that we have created, we have instantiated the employee class. We use that to call the greet method, right? So Python automatically passes emp1 as self. Now the class understands that our employee 1 is John, who is a manager. This is possible because of the self keyword over here. So this is what is connecting our object and our method over here. So it is the self keyword that is connecting our object and our method. So it is the self keyword that is connecting our object and the method that is in our class over here. Now moving on to the next question, what are class methods and static methods and how are they different from instance methods? So now in order to answer this question, you need to know class methods, you need to know static methods, and you need to know instance methods. So the strategy that we would follow would be to explain these three methods, give examples for all of them, and maybe give a few key pointers that differentiates the three, right? So first we'll begin with class methods. We'll explain what they are. So basically a class method is tied to the class itself. It is not an individual instance of a class. Rather, they modify the class state or class level attributes. They do not modify a specific object instance, right? Instead of using self, class method takes CLS as their first parameter, which refers to the class itself. One important point is the class methods are defined using @class method, right? So this is a decorator that lets us define the class methods, which tells Python that the method works with the class and not a particular instance, right? So let's look at how the class methods are implemented. So you can see over here, we have a class dog. It has a global variable species, global variable inside the class, right? We have our dunder method over here, And then we're creating a class method. As you can see, we have declared it with the decorator over here. And we are calling a method change species. And our first argument over here is CLS. And our second argument is new species. So over here, this is our default species name. But if we want to change it, we can use the change species method, and our variable species is going to be affected globally inside the class, right? Let's go ahead and run this program. So you can see instead of canine, our species has become feline, right? Our input over here as we changed it using dog.changeSpecies. So this is what class instance means. So now let's look at our static methods. So static methods are quite different from both the instance and class methods because they do not really depend on any instance or class specific data. So a static method is basically a regular function, but the only difference is we include these static methods inside a class to make our code look neater and for better organization. So static methods are again defined by the decorator called static method and using @ as a prefix. So they do not take any self or CLS as parameters. And they are usually utility methods that perform tasks that don't involve accessing or modifying class or instant data. Static methods are really useful when you need a method that logically belongs to the class but doesn't need to access any class or instance specific data. So let us see how that is done. So you can see we have a class dog over here, and again we have a static method dog age in human years. So what we're doing here is we are converting dog age to human years. Now this does not require any sort of attributes from the class. Rather, we're simply going to pass our argument when we call the method itself, and it is simply going to return. So it does not need to access any class level or instance level data. So no self or CLS is required. Rather, it is simply going to multiply 7 to our past argument and return that. So this is why static methods do not require any sort of arguments as self or CLS. Then our next method is instance method. So instance methods always take self as their first parameter. As you might have seen the init or the dunder method, they always take self as their first argument and then whatever parameters are required for the function, right? So this is one example of instance method. They always require self as their first parameter. Self basically refers to the instance that calls the method. As we have already seen in the previous question, self is basically the bridge that connects the method and the instance that calls the method, right? So using this, they can access instance specific data or the attributes and perform actions on that data. So let us quickly look at the code for instance methods. So you can see over here, we have our instance attribute name and breed, and we create an instance method bark, and that bark is basically going to print name says wolf, right? Whatever name we pass as a parameter, we passed buddy over here, so buddy says wolf is what is going to be printed. Let's see. So buddy says woof. Golden retriever is our breed over here, which we are not really using in our method, so it is nowhere being printed. So this is how instance methods work, or they are implemented in Python, right? Moving on to our next question, explain the differences between a set and a dictionary. Now we know a set and a dictionary are both built-in data structures, right? So you can see in this image, a set is somewhat stored like this. So we have different elements stored in curly brackets. We know dictionary also use curly brackets, but the only difference is they use key value pairs. So basically we'll have a key called B, which will be pointing to the value beauty using colons, right? We have J for joy and C pointing to computing, right? So now the main properties of set is that they are unordered and they're unique, right? They will never store duplicate values. So sets will never store duplicate elements. So this was just an overview. We'll go ahead and look at the differences in detail. So sets don't really care about any order, right? They're unordered. The items are not stored in a specific sequence. So say if you were to insert the elements A, B and C in that particular order itself, A, B and C. So say this is stored in set C. So the order could be B, C, A, or it could even be B, A, C. So it is completely unordered, right? It does not follow a specific location or a specific. And the main rule for sets is that every item inside the set must be unique. That is, no duplicates are allowed. So this is useful when you want to avoid duplicates or quickly check if something exists in the collection. So in Python, sets are unordered, meaning they don't maintain the order in which you add items. You can't refer to items by an index like you can with lists and tuples. So if you were to store your elements, say A, B, and C in a list at the indexes 0, 1, and 2, you could easily access A at index 0, B at index 1, and C at index 2. But that is not the case with sets because, as I told you, they're unordered, so their indexes are not fixed, right? A could be at index 0 in the first time you printed, and the second time you printed, it could be at index 1. So this is why you cannot access them through indexes. And they're also useful to check if an item exists because, again, you will only have unique items, so there won't be any duplicate items. And to check if an item exists, there will be fewer number of passes or iteration, right? And lists are also mutable. That is, you can easily add or remove items from a set. And then we have dictionary. So dictionaries are key value pairs. They're like a real world dictionary where you have words as keys and their meanings as values, right? You would pick up any dictionary that you have. You will have a similar implementation in that dictionary. So in Python, a dictionary is again a collection of key value pairs, and every item has two parts, a key and a value. Another analogy of a dictionary could be an address book where you store people's names, which would be the keys, and their phone numbers and other details about the person, like their address, as their values. So in dictionaries, the keys must be unique, right? So now in dictionary, the keys must always be unique. Just like in a dictionary, how each word is unique, similarly, dictionaries in Python also have unique keys. And then the values, on the other hand, can be anything, right? They can be strings, numbers, lists, even other dictionaries, and they do not need to be unique. So the values do not really follow any constants over here, but the keys need to be unique and they need to be immutable as well. Dictionaries as a whole are mutable, but the keys, the data types that are used for the keys need to be immutable. So now let's quickly differentiate between the two using some pointers. So let's look at the structure of the two data types, right? So sets contain individual items with no associated pair, just unique elements, whereas dictionary contain key value pairs where each key is associated with a value, right? Now then let's look at the purpose. So sets are used when we need to collect unique items and we do not care about their order. For example, when we need to collect the unique words from a text, right? Whereas dictionary is used when we need to map one item to another. For example, storing people's contact details where names are the keys and phone numbers are the values, right? Next comes order. So set is unordered. The order of the elements does not matter. And dictionaries are ordered. That is, keys and values are kept in the order you add them, right? Then comes accessing the elements. So you can only check if an item is present, add or remove items, but there's no index or key to directly access a particular item. Whereas dictionaries, you can access the values by referring to their associated keys, right? So this was the difference between a set and a dictionary. The more points you remember, the better, because again, the interviewer is looking for as much information you can give to him or her during an interview. Then the next question is, what is the time complexity of inserting elements in a linked list? Now, whenever these kind of questions are thrown at you during an interview, do not directly start with the time complexity and do not ever give direct answers to the interviewer. Always start with breaking down from the most complex part. So we'll start and first understand linked list, right? So linked list, maybe you can give a one-liner about what is linked list, what do you understand about linked list, and then move ahead with the answer, right? So a linked list is again a data structure where each element is called a node, and it contains two parts. So as you can see over here, this is one node, right? So as you can see over here, this is one node, and this node has two parts. One is the data, and one is the reference or a pointer which links to the next node in the list, right? So unlike an array where elements are stored in contiguous block of memory, a linked list stores its elements in separate nodes that are scattered in memory but connected by references. So the only way we know that B is stored after A is because there is a pointer from node A to node B telling us that there is another node which contains the data B, right? And how do we know that this is the first node? Because we have our head pointer pointing to this node. Because we have the pointer of this node pointing to null, which is basically telling us that there is no further node and I am the last node, right? So the time complexity for inserting elements in a linked list depends where we're inserting that element, right? If we're inserting that element at the beginning, we would have a time complexity as 1. We would have a time complexity as 1 because this operation is very simple. If you're inserting a new element at the head of the linked list, you just have to create a new node, make this node, you just have to create a new node, make this node's pointer point to the current head node. Like this was our previous current, repeat, this was our initial head node, right? So the pointer of this node is going to point to the current head node, and the head has to be pointed to our new node. This operation is always going to be performed in a constant time, meaning it is going to take the same time no matter how many elements are there in the linked list. So the time complexity is big O of 1. The next operation is inserting the element at the end. So this can be a little more complex depending on the setup. So if you don't have direct access to the tail node, you need to traverse the entire linked list to find the last node, which takes big O of n time, where n is the number of nodes. So once you find the last node, inserting the new node is again a constant operation. It's just going to take big O of 1 time because you just need to update the last node. All you have to do is update the last node's pointer to the new node and update the new node's pointer to null. This operation is always going to take big O of 1 time because it's a constant operation, but the overall time complexity is going to increase because of traversing through the entire linked list, right? And then we have our last operation, which is inserting the element anywhere in between the linked list or at a specific position. So this operation is again going to take big O of n time, because in order to find where exactly you need to insert the element, you will have to traverse through the linked list to find that position. For example, if you want to insert at position k, you have to traverse k nodes to reach that spot, right? After you find the correct position, the actual insertion operation is again big O of 1, right? This operation is only going to cost us big O of 1, but the actual complexity is going to increase for traversing through the linked list. So the overall time complexity over here is big O of k, where k is the number of nodes, where k is the number of nodes that you have to traverse in order to reach the insertion point. But since big O always considers the worst case, what if you have to insert your element right at the end, right? So k is going to be almost equal to n, where n is the total number of nodes. That's why we're going to have our time complexity as big O of n, right? So I hope this was clear. Moving on to our next question. How do you find the middle element of a linked list in one pass? Now, finding the middle element of a linked list is no big deal, because if the interviewer was to ask you to find the middle element of a linked list, it would be very easy. All you would have to do is traverse through the entire linked list, keep track of the number of nodes. Say the number of nodes over here are 5. So you could easily use a formula and figure out that your middle element or your middle node is at index, is the third node. So you would easily be able to figure out that your middle node or your middle element is the third one. right? But the constant over here is one pass. So what does one pass mean? It means you traverse the linked list only once. You don't get to go back or have multiple iterations through the list. That means you can only traverse through the linked list once. You cannot go here, come back, and then go through the list again and then stop at the third node, because you figured out that the total number of nodes are 5, and therefore your middle node or your middle element would be the third one, and you would then return the data stored in the middle node. So that cannot be the case, because you need to do the entire thing in one pass. So this is where the two-pointer technique comes in the picture. So this two-pointer approach basically uses a slow and a fast pointer, right? As you can see in this diagram, the slow pointer is going to move one step at a time, and the fast pointer is going to jump one node in between and is going to move 2 steps at a time. So it is pretty evident from this diagram, when our slow pointer is at the middle, our last pointer is going to be at the our fast pointer is going to be at the last node. So this is basically our condition, right? Whenever our fast pointer reaches null, like whenever the fast pointer reaches the last node, our slow pointer is going to be at the middle node. So this is the approach that you can follow and explain to the interviewer in detail. So you can also explain that since the slow pointer covers only half the distance in the same time as the fast pointer covers the full distance. So this is the main reason why we would have a slow pointer pointing to the middle element while the fast pointer is at the last node, right? Now, this is a very simple explanation, but in order to stand out, you should also consider the edge cases, right? Like if you have odd number of nodes, say you have only 3 nodes, in this case, the fast pointer will reach the end node and the slow pointer will be exactly in the middle node, right? So our slow pointer would start here with the fast pointer. Say this is our fast pointer. So the slow pointer would be exactly at the middle node and there would be no complications as such. But in case of even number of nodes, we have our slow pointer here and a fast pointer over here. When we have a slow pointer here, our fast pointer would be over here. When our slow pointer goes here, our last pointer would be pointing to null, which means out of these two, one of them is our middle element. So this is where you need to decide which one of your nodes you want to consider as a middle node and pass the element of that node as a middle element, right? So this is a very important edge case that you need to consider. So moving ahead with our next question, which is an implementation based question. You will usually find these questions in the final round of your interview. So I would say the difficulty level would increase over here. You have to write a function that will implement a logic such that whenever the function takes a string as input, it should return the length of the longest substring that contains no repeating characters. Right, so for example, you have this string over here, and as you can see from FAVTU, we have no repeating characters, but the moment we come across this T again, we know it's a repeating character. So again, our longest substring without any repeating characters is 5, right? 1, 2, 3, 4, 5. Similarly, over here, we have another string called Python. So as you can see over here in this Python string, we do not have any repeating characters. So the entire string is a substring without any repeating characters. Right, so these are the two cases. Let us look at the implementation in detail. Right, so this is the way you will be given the question. You will be given examples where you will be given the sample input, the sample output, and the explanation. So this is the common approach the companies follow whenever they give these kind of questions, right? Implementation based questions. So we have an input over here, A, B, C, B, B. Now the longest substring we can find over here is A, B, and C. Because the moment we move from C to A, we know this is a repeating character. And then again, B is also a repeating character. And then B over here is also a repeating character. Right? So our longest substring is A, B, and C. Then similarly, we have another example, which is B, B. Right? So our longest substring is just going to be with one character B, because all are repeating over here. Then we have another one which is PWWKEW. Now our longest substring can be either KEW or WKE, right? So the answer is going to be 3 over here, no matter what. So this is the main logic behind this question. So first what we're going to do is look at the brute force approach. Now what the brute force approach says is you have to generate all the substrings for a given string. Now say I have this string over here, right? So what we're going to do over here is run 2 loops over here. So you can say my first loop I and second one is j, right? So now what I'm going to do is I'm going to generate all my substrings starting with character A over here, right? So I'm going to keep moving my j forward till I have all the substrings generated starting from A. So my first substring is going to be just A, then it's going to be A, B, then it's going to be A, B, C, and then it's going to be A, B, C, A, right? So I'm going to generate all my substrings like that starting from A. Then I'm going to increment my I, and then I'm going to have my second set of substrings starting with B, right? So it's just going to be B first, then it's going to be BC, then it's going to be BCA, and so on, right? So I'm going to do that with all the substrings, and then I'm going to check whether the characters in all the substrings are unique. Now over here I have unique characters, over here I have unique characters, so my maximum length is going to be 2 over here. For initially it's going to be 0, then it's going to increment to 1, then it's going to increment to 2, because again 2 is greater than 1, and then we're going to move over here, which is 3. But over here you can see I have a repeating character, so my maximum length is going to remain 3, right?
Yeah.
Similarly, we're going to do that for all the substrings. Now imagine the complexity in this kind of approach. It is going to be really high, right? We'll be running 2 for loops, so the complexity goes to n square automatically, and then we're going to have to do a lot of comparison and a lot of operations in a brute force approach. So that is why we have come up with a simpler or an optimized version or an optimized solution, which is a 2-pointer method, or it is also known as sliding window. So what we do over here is, so let us look at the steps real quick. So we start with a left and right pointer. So instead of running our loops with I and j, now we're going to run it with our left and right pointers, right? And our left pointer is initially going to be at 0, and our right is also going to start with 0. And then what we're going to do is we're going to increment our right pointer until we come across a repeating character, right? So now our main condition over here is if our right pointer comes across a repeated character, we simply have to increment our left pointer by 1 plus the index of our last occurring character. Now this might sound a little confusing over here, but let us quickly look at the logic behind it. So we again have this sample string. We have our left pointer here and our right pointer here. Our maximum length is initially 0. Now we know that our right pointer has come across A, so we're going to create a hash map or a dictionary, and we're going to map A with index 0. And then we're going to increment our right pointer by 1, and then it's going to point to B. So now our maximum length is going to be 1, right? So B is again not a repeating character, so we'll map it with the index 1. Then we come across C, which is at index 2, and we increment our maximum length to 2. And now our maximum length is 3, right? Initially it was 0, then we came across A, which it was incremented to 1. When we came across B, it was incremented to 2. Then when we come across C, it is incremented to 3, right? Then we come across A. Now this is a repeating character. So what we're going to do is we have to increment our left by the index of A, which was initially 0, plus 1.
Yeah.
So now our left is going to point to B. And then we update the index value of A as well. So now the last time we found A was at index 0, 1, 2, 3. Right? So this is how we run the loop. Now let us complete this. Now our right points to B, which is again a repeating character. So we follow a similar approach. We are going to increment our left by 1 plus 1. So it is going to point over here at C. And then we increment our index value of B to 4. Right? So now our substring is from here to here, which is stuck at 3 itself. And then we increment our right pointer again. So again, this is a repeating character. We update the value over here and we increment our left pointer by our previous value was 2. Now it is 2 plus 1. So it is 3. Our left pointer is going to point at A. So now our string is from here to here. Right? So A, B, C, D. So this is our longest substring over here, as you can see. So our maximum length turns out to be 4 at the end. And then we update the value of D as well. So it is at 0, 1, 2, 3, 4, 5, 6. Right? So this is the basic logic behind two-pointer method or the sliding window method, which is really simple if you get a hang of it, and it is super easy to implement. So now let us quickly go ahead and look at the code for the same. So this is again a very short 18 lines of code, not even 18 lines. So let us quickly go ahead and look at it. So we created a function length of longest substring. We passed a string over here. We have initialized a maximum length variable to 0. Our left pointer is also at 0. And we created a dictionary called character count. Now we run a loop and we are going to increment our right pointer in this loop. So our current character is the character that the right pointer is pointing at, right? So we stored it in a variable called current. Now if our current character is present in our dictionary, that is, it is a repeating character, and the index value of that particular character previously is greater than our left pointer, then we are going to increment our left pointer, right? So this is the main logic that we have implemented. Now after implementing the if condition, we come out and we update our maximum length value, and we also update the index of the character, right, in our dictionary. And after coming out of this entire for loop, so see over here we are running the for loop only once. So this is directly decreasing the complexity of our program. And then we simply return the maximum length value, and let's run our program to check it once. So here you can see 4 is our maximum length of substring without any repeating characters. So yes, it was a very easy problem. So yes, it was an easy problem, and I hope you guys got a hang of it and will be able to implement it on your own. So now our 29th question is again a very interesting one, and it is very commonly asked in a lot of interviews. This is also known as the 0-1 knapsack problem. Let me just write it down for you guys. So this problem is also known as the 0-1 knapsack. Now 0-1 means either nothing or the entire thing, 0 or 1, right? There's no fraction over here. Either we take the entire thing or we don't take it at all. So you're given a set of items, each with a weight and a value. So now we have a weight for each item and we have a value for it. So the value is $4, and we'll consider any kind of currency. It could be rupees, dollars, anything. Basically it has some value and it has a weight also. Your task is to figure out how to pack the most valuable items into a knapsack without exceeding its weight limit. Now we have a knapsack over here, which is nothing but a backpack, and we have a capacity for our backpack. Over here it is 15 kgs. So now each item either can be taken or it can be left behind. We need to find a method where we can keep the most valuable items. Like we should have the maximum value out of all the things we take in a knapsack, right? So let us look at the approach. So this is how you will be asked the question in interviews. You will be given the problem statement and you will be given some constraints, and then you will be given sample inputs and outputs. So over here we have A as our values associated with the items, B is our weights, and C is the capacity of our knapsack or our bag, simply. So let's look at this. Now we have the bag capacity as 8, right? And we have 4 items over here, and each item has a weight and a price. Now if we were to check the items one by one, if we were to follow the brute force approach, what we would do is we would consider all the items one by one and consider the possibilities as well. So if we talk about item 1, okay, let's say I have 4 items over here. So now this item has only two possibilities. It can be taken or it cannot be taken, right? This also has two possibilities. This again has two possibilities, and this also has two possibilities. Now, if I were to have n items like this, each having two possibilities, my complexity would turn out to be somewhere around 2 to the power n, which is again very high, right? So, what I am going to do over here is I'm going to implement something known as dynamic programming. So, what dynamic programming does is basically it helps you break down the complex problems into smaller chunks, and it makes your solution more manageable, right? So, we're going to look at the approach for dynamic programming over here. So, over here, let's call our table as V. Let's call these columns as J, and let's call our rows as I. Right? So, V is our entire table. So, I hope you guys are not confused. And over here, we have our capacity, and over here, we have our weights. So, now if our capacity is 0, we cannot have any profit, or we cannot put in any weights. And if our weight is 0, again, we will not have any item in our bank. So, this is the first step to solving the problem. So, now considering this example over here, I'm going to fill my table. So, now I have my weights as 2, 3, 4, 5, right? Let me just write it down. And I have my profit associated with these weights as 1, 2, and 5, 6. Right? So, let me show you how to fill this table without using the formula, and then we're going to fill the last few values using the formula as well. So what we're going to do is, as we go down these rows, we are going to consider the previous items as well. So if we are over here, there's no previous item, so it is just this item. But when we are considering this second item over here, we have to consider the first item as well. And similarly, as we go down. So what we're going to do here is, we have to consider the previous rows. So our maximum value is going to be 0. Now if our weight is 2, the profit can be 1. So now we have to consider these previous columns, previous cells, and according to these, we can fill our next values. So it is going to be 1. And now you can see over here, our weight is 3 and our profit is 2. So whenever our capacity of the bag is 3, our profit is going to be 2. Then as we move along the line, now you can see when our capacity of the bag is 5, we can have the weight, the maximum profit as 3. So we have to consider the previous weights as well, right? So now based on the previous values, we're going to fill the previous cells. Over here, our maximum profit is going to be 2, then it's going to be 3, right? Then when we have our weight as 4, our profit is going to be 5, right? But when we have our capacity of the bag is 6, which is 4 plus 2, our profit is also going to be 6. But when our capacity of the bag is 7, which is 4 plus 3, our profit is also going to be 7. And now we can fill these previous cells based on our previous values over here. It's going to be 0, this is going to be 1, this is going to be 2, this is going to be 5. Maximum of these is 7, so 7, right? Now let's fill this last one using the formula. So now the formula goes like, let me just write it down for you. So V is the table, V of I and J. So V of I comma J is going to do nothing but locate a particular cell for us using the row and the column value. So this is equal to the maximum of V of I minus 1 comma J, or V of I minus 1 J minus W, Wi you can say, plus P of I. Now P of I over here is nothing but the profit associated with I, right? So now let's try and find this value using the formula. So we have table of I is 4 and our J is 1. So maximum of I minus 1 is 3 and J is 1. So 3 comma 1 is this this cell over here. So we're considering this cell and we're going to compare it with I minus 1 is 3. J is 1. 1 minus the weight associated with I. So our I is 4, right? So the weight associated with the fourth item is 5. So it is basically 1 minus 5 plus the profit is 6. Now if I subtract this is going to be minus 4. And we do not have any cell that is pointing to 3 comma minus 4. So this is again invalid and we are directly going to consider this. So this has a value of 0. So we're going to fill 0 over here. Similarly, you can do that for all the cells over here. I'm going to do it directly, but you can go ahead and give it a try, right? So now whenever our weight is going to be 5, our profit is going to be 6. And similarly, when my capacity is going to be 8, my weight is also going to be 8 over here. As you can see, 6 plus 2. 5 plus 3 is 8 and my 6 plus 2 is 8 again. So the rest I can fill directly. And as you can see, this cell is giving me the maximum profit my knapsack can have when the capacity is 8. So the answer is 8 itself. So this is how dynamic programming works, and this is how the tabular approach is for dynamic programming. So this is our optimized solution for a 0-1 knapsack problem. And what we're going to do is quickly look at the code for it. So here we have our profits, we have our weights, and W is the capacity of our bag, and N is the length of profit, or you can see the number of items, right? So we're passing all this in a function. So we create a table K over here, and we're going to do this in bottom up manner. So again, we create 2 for loops to fill our table. So whenever we have a row or column equal to 0, we are directly going to fill 0 in our table, right? And this is the condition, or this is the formula that we discussed, and we're simply going to implement it over here. And finally, we're going to return the last cell and print it, right? Let me just run this program for you. And as you can see, 8 is our maximum profit associated with the particular capacity for our knapsack bag. And then we have our last question for the series, which is the asteroid collision problem. So now what the problem statement is here, you are given a series of asteroids which are moving in a straight line. Now whenever there's going to be a collision, they will either destroy each other or they will continue moving forward. So now your task is to determine the final state of all the asteroids after the collisions. So now, as you can see, you're given a number of asteroids. Over here, you're just given 4 asteroids. And you have some asteroids moving in the right direction and some moving in the left direction. Now, how you're going to approach this problem is, you will go to the first asteroid. You will check its direction. Basically, if it has a positive magnitude, it's going to be moving in the right direction. And if it has a negative magnitude, it's going to be moving in the left direction. Simple enough. So now what you're going to do is, you look at the first asteroid, you see the magnitude and you know it's moving in the right direction. Then you move to the next asteroid. You check, again it has a positive magnitude, so it is going to be moving in the same direction as the last asteroid, so there will be no collision over here, right? Then you move to the next asteroid and you see that the previous asteroid and your current asteroid are moving in opposite directions. So now there is going to be some collision over here, right? So what do you do in this case? You check the magnitude of both the asteroids. Now this has a greater magnitude, so this asteroid is going to survive after the collision, whereas this one is going to get destroyed. Correct? So now that you know this asteroid is destroyed, you will not consider this asteroid in the picture, right? You move on to the next asteroid. Now this asteroid and this asteroid needs to be compared. So now this one has a greater magnitude, so this asteroid is going to be destroyed, right? Now we have these 2 asteroids in the picture. So now this one again has a greater magnitude, so this asteroid is again going to be destroyed. So now after all the collisions, the final state is just going to be minus 15. There is just one asteroid that survived and it is moving in the left direction. That is all you have to figure out using a very basic implementation. So let's look at the logic behind it in more detail. So again, this is how you're going to be given the problem statement. You'll be given the description and then you'll be given some sample examples, and you will also be given some constraints for your variables, right? So let's look at these examples first. So here you have 5, 10 and minus 5, right? So this is moving here, this is moving here, this one is moving in the opposite direction. So these two asteroids will collide naturally, and you have this one with a greater magnitude, so this one gets destroyed, and your final state is 5 and 10, right? So this has to be your output over here. Then the next one is 8 and minus 8. So now this one is moving in this direction and this one is moving in the opposite direction, and they have the same magnitude. If you ignore the sign, they have the same magnitude, but since there will be a collision, they both will get destroyed with each other, and you will have no asteroids left. So an empty output. Then finally you have another example, 10, 2 and minus 5. Now our first collision is going to happen over here, and this asteroid is going to destroy this one. And then finally we're going to have 10 and minus 5 having a collision, and this one is going to get destroyed. So 10 is our output. Correct? Now you might have gotten a basic idea about this, and you might have realized that you need some sort of LIFO structure over here to maintain this, right?
Yeah.
All you're going to do is you're going to put the positive asteroids in your stack and then compare the top of the stack with the asteroid that's going to be colliding. Let's look at the example. Let's take 10, 2 and minus 5 for example. So we have 10. We'll put it in the stack because it's moving in the right direction. Then we have 2. It is again moving in the right direction, so we'll again put it in a stack. Then we have minus 5. Now we'll compare our minus 5 with our top of the stack element, which is 2. So now we know this asteroid has a greater magnitude and is going to destroy this particular asteroid. So we pop it out. We're going to pop this asteroid out, and we're going to compare our top of the stack element again with our current asteroid. And now we know this asteroid is going to destroy this one. So we move on to our next asteroid. But again, we do not have any other asteroids, so we just return a stack. Correct? So this is the basic idea. So now let's look at the implementation of this particular program. So we have a function asteroid collision. We pass all our asteroids. So our asteroids is nothing but a list of the asteroids that we have. Right? We pass it in our function. So now what we're going to do is simply create a list to avoid extra operations, and we'll go through each asteroid. We'll run a loop in our list itself. So we're saying ast in asteroids, and we're saying add asteroid equal to true by default. Right? So what we're saying is add the asteroid in the stack is true. Like go ahead and add this particular asteroid in the stack. But now we cannot add all the asteroids in the stack. So we are going to check for the particular conditions. So now we're saying while our stack is not empty and our asteroid is less than 0 and the top of the stack element is greater than 0. So while these conditions are true, we're going to stay in this loop, and we're going to check if the top of the stack element has a greater magnitude than our current asteroid where there is a collision. So this particular condition is basically checking for a collision, right? And then what we're doing is we're checking if our top of the stack element is greater or our current asteroid is greater, right? Now if we find that our top of the stack element or our top of the stack asteroid is greater than our asteroid moving in the left direction, the opposite direction, we are not going to add that particular asteroid. So we make this condition, we make this variable as false, and we break out. But if we find that our top of the stack element is equal in magnitude to our asteroid moving in the opposite direction, we're simply going to pop that particular asteroid from our stack. That is, we're going to remove it, and we are again going to add asteroid equal to false, because we do not want that asteroid being added to our stack as well, because they're both being destroyed. And again we break out of the loop. But again, if both these conditions are not true, that is, if our top of the stack element is not greater, that is, it is having lesser magnitude than the other asteroid, we are simply going to remove that particular asteroid from the stack, and we are going to add the other asteroid in our stack, as you can see over here, right? But this is going to happen only when the collision condition is false. That is, we move out of this condition, we add our stack, and then finally we return our stack. Let's run this program. So here we have minus 18 and minus 19. Let us quickly look at this example, right? So if we consider this example, we have, let's put it in a stack and see so that it becomes more clear. Right, so this is a stack. I add 4, then I add 7, then I add 1, then again I add 1, then again I add 2. Now I have minus 3. Right, so now I'm going to compare this with this. So now I know this has a greater magnitude. So I'm going to follow my last condition, which is simply popping this element out. Right, I pop this element out of my stack. Now again I'm going to check this with this. So again this is going to be removed or it's going to be popped, right? Then I check this element with this one. So again it is going to be popped, or I can just erase this from my stack. And then I'm going to check this asteroid with this one. So now this one gets destroyed and I move to the next one. Now this is minus 7, this is positive 7, both get destroyed, right? So I'm going to pop this element out of my stack and that one also gets destroyed. So I'm going to move to the next one and it's positive, so I'm going to add it. Like there's no collision, so I'm going to add it and my pointer is also going to move up. Then I move to the next one and again there's no collision, so I add it. And now there's minus 18. So I'm going to compare it with my top of the stack element. So it is going to pop this out, right? Then I'm going to compare it with this one. So again it has a greater magnitude. I'm going to pop this out. Then I'm going to compare it with this one. Again it gets popped because minus 18 is greater than 4. So now I do not have anything else to compare my current asteroids with, so I'm simply going to add them in the stack because my add asteroid condition is true over here, right? So I'm going to add it and then I'm going to return the stack. So this is also what the code is implementing in the program, right? So I hope this was clear and I hope you guys got a good understanding of implementing the optimized version of the solutions, not just how you implement the solutions. And if you have any sort of doubt, comment below and I will get back to you as soon as possible. So if you want to know more about such courses, you can call on these numbers or you can contact with our 24/7 available chat and get more details about it. So thank you and see you in the next video.